We live in difficult and challenging economic times, of course, and one of the first victims of difficult economic times, I think, is, well, public spending of any kind, but certainly in the firing line at the moment is public spending for science, and particularly curiosity-led science and exploration. So I want to try and convince you in about 15 minutes that that's a ridiculous and ludicrous thing to do. But I think to set the scene, I want to show, the next slide is not my attempt to show the worst TED slide in the history of TED. It is a bit of a mess. But actually it's not my fault, it's from the Guardian newspaper. It's actually a beautiful demonstration of how much science costs, because if I'm going to make the case for continuing to spend on curiosity-driven science and exploration, I should tell you how much it costs. So this is a game called Spot the Science Budget. This is the UK government spend. You see there it's, well, 620 billion a year. The science budget is actually, if you look to your left, there's a purple set of blobs and then a yellow set of blobs. And it's one of the yellow set of blobs around the big yellow blob. It's about £3.3 billion per year out of 620 billion. That funds everything in the UK, from medical research, space exploration, where I work at CERN in Geneva, particle physics, engineering, even arts and humanities are funded from the science budget, which is at 3.3 billion, that little tiny yellow blob around the orange blob at the top left of the screen. So that's what we're arguing about. That percentage, by the way, is about the same in the US and Germany and France. R&D in total in the economy is something like, publicly funded, is about 0.6% of GDP. So that's what we're arguing about. The first thing I want to say, and this is straight from Wonders of the Solar System, is that our exploration of the solar system and the universe has shown us that it is indescribably beautiful. This is a picture that actually was sent back by the Cassini space probe around Saturn after we'd finished filming Wonders of the Solar System, so it isn't in the series. It's of the moon Enceladus. So that big sweeping white sphere in the corner is Saturn, which is actually in the background of the picture. And that crescent there is the moon Enceladus, which is about as big as the British Isles. It's about 500 kilometres in diameter, so a tiny moon. What's fascinating and beautiful, this is an unprocessed picture, by the way, I should say, just black and white, straight from Saturnian orbit. What's beautiful is you can probably see on the limb there some faint sort of wisps of almost smoke rising up from the limb. This is how we visualise that in Wonders of the Solar System. It's a beautiful graphic. What we found out were that those faint wisps are actually fountains of ice rising up from the surface of this tiny moon. Now that's fascinating and beautiful in itself, but we think that the mechanism for powering those fountains requires there to be lakes of liquid water beneath the surface of this moon. And what's important about that is that on our planet, on Earth, wherever we find liquid water, we find life. So to find strong evidence of liquid, pools of liquid beneath the surface of a moon 750 million miles away from the Earth is really quite astounding. So what we're saying essentially is maybe that's a habitat for life in the solar system. Well, let me just say that was a graphic. I just want to show this picture. That's one more picture of Enceladus. This is when Cassini flew beneath Enceladus, so it made a very low pass, just a few hundred kilometres above the surface, and took to this again a real picture of the ice fountains rising up into space. Absolutely beautiful. But that's not the prime candidate for life in the solar system. That's probably this place, which is a moon of Jupiter, Europa. And again, we had to fly to the Jovian system to get any sense that this moon, as most moons, was anything other than a dead ball of rock. It's actually an ice moon. So what you're looking at is the surface of the moon Europa, which is a thick sheet of ice, probably 100 kilometres thick. But by measuring the way that Europa interacts with the magnetic field of Jupiter, and looking at how those cracks in the ice that you can see there on that graphic move around, we've inferred very strongly that there's an ocean of liquid surrounding the entire surface of Europa. So below the ice, there's an ocean of liquid around the whole moon. It could be hundreds of kilometres deep, we think. We think it's salt water. And that would mean that there's more water on that moon of Jupiter than there is in all the oceans of the Earth combined. So that place, a little moon around Jupiter, is probably the prime candidate for finding life on a moon or a body outside the Earth that we know of. Tremendous and beautiful discovery. Our exploration of the solar system has taught us that the solar system is beautiful. It may also have pointed the way to answering one of the most profound questions that you can possibly ask, which is, are we alone in the universe? Is there any other use to exploration and science other than just a sense of wonder? Well, there is. This is a very famous picture taken actually on my first Christmas Eve, December 24th, 1968, when I was about 8 months old. It was taken by Apollo 8 as it went around the back of the moon, Earthrise from Apollo 8. A famous picture. Many people have said that it's the picture that saved 1968, which was a turbulent year, the student riots in Paris, the height of the Vietnam War. The reason many people think that about this picture, and Al Gore has said it many times actually on the stage at TED, is that this picture arguably was the beginning of the environmental movement, because for the first time we saw our world not as a solid, immovable, kind of indestructible place, but as a very small, fragile-looking world just hanging against the blackness of space. What's also not often said about the space exploration, about the Apollo program, is the economic contribution it made. I mean, whilst you can make arguments that it was wonderful and a tremendous achievement and delivered pictures like this, it cost a lot, didn't it? Well, actually, many studies have been done about the economic effectiveness, the economic impact of Apollo. The biggest one was in 1975 by Chase Econometrics. And it showed that for every $1 spent on Apollo, 14 came back into the US economy. So the Apollo program paid for itself in inspiration, in engineering, achievement, and I think in inspiring young scientists and engineers 14 times over. So exploration can pay for itself. What about scientific discovery? What about driving innovation? Well, it looks like a picture of virtually nothing. What it is a picture of the spectrum of hydrogen. See, back in the 1880s, 1890s, many scientists, many observers looked at the light given off from atoms, and they saw strange pictures like this. What you're seeing when you put it through a prism is that you heat hydrogen up and it doesn't just glow like a white light. It just emits light at particular colours, a red one, a light blue one, some dark blue ones. Now that led to an understanding of atomic structure, because the way that's explained is that atoms are a single nucleus with electrons going around them, and the electrons can only be in particular places, and when they jump up to the next place they can be and fall back down again, they emit light of particular colours. And so the fact that atoms, when you heat them up, only emit light of